Hi everyone, this is Ms. Shea. In this video, we will be looking at how to propagate uncertainties. After watching this video, you will be able to determine the uncertainty of an answer to a calculation. First, we'll look at what to do with uncertainties when we add or subtract. When we add or subtract measurements, the uncertainties are added together. Let's do an example. Determine the volume of the sample of gold using the water displacement method. The initial volume of the water without the gold is 17.2 plus or minus 0.5 cubic centimeters. And the final volume of the water with the gold is 19.9 plus or minus 0.5 cubic centimeters. To find the volume of the gold, we need to subtract the final volume by the initial volume. So 19.9 plus or minus 0.5 cubic centimeters minus 17.2 plus or minus 0.5 cubic centimeters. When I subtract 19.9 by 17.2, I get 2.7. Then we simply add the uncertainties, 0.5 plus 0.5. So the final answer is 2.7 plus or minus 1.0 cubic centimeters. The process for propagating uncertainties when we multiply or divide is a little more complicated. When measurements are multiplied or divided, the percentage uncertainties are added together. To find the percentage uncertainty, we divide the absolute uncertainty by the measured value, then multiply by 100. Let's look at how this works. Determine the density of the sample of gold if its mass is 50.442 plus or minus 0.001 grams. We know from our earlier calculation that the volume is 2.7 plus or minus 1.0 cubic centimeters. Density is calculated by dividing mass by volume. So the density of the sample of gold is 50.442 plus or minus 0.001 grams divided by 2.7 plus or minus 1.0 cubic centimeters. We'll convert the absolute uncertainties to percentage uncertainties. For the mass measurement, 0.001, the uncertainty, is divided by 50.442, the measured value. Then multiply by 100 and we get 0.002%. For the volume measurement, 1.0, the uncertainty, is divided by 2.7, the measured value. Then multiply by 100 and we get 37.037%. So now we substitute the absolute uncertainties with the percentage uncertainties. Density is equal to 50.442 grams plus or minus 0.002% divide by 2.7 cubic centimeters plus or minus 37.037%. 50.442 divided by 2.7, rounded to two significant figures, is 19 grams per cubic centimeters. We add the percentage uncertainties together, 0.002 plus 37.037, and we get 37.039%. So the density of the gold sample is 19 grams per cubic centimeter plus or minus 37.039%. This can be our final answer. We can also convert the percentage uncertainty back to absolute uncertainty by reversing the formula. In this case, we would divide 37.039 by 100, then multiply by 19. And the density turns out to be 19 plus or minus 7 grams per cubic centimeter. Try these two examples by yourself, and we will discuss the answers in class.